welcome to our first session of probability. So what is probability? Probability theory deals with events of chances. So as you're going to see, as we're going to cover throughout this probability, we are mainly going to be dealing with chances. What's the possibility of something happening? And probability of any event occurring is equal to the number of ways the event can occur out of the number of total possibilities. Simply put, probability is equals to the desired chance. So this is the basic formula we shall use. Desired chance out of the total number of chances. So when you ask to find the probability of anything, it's the desired chance out of the total number of chances. For example, what's the probability of a coin tossed giving us a tail, for example? So in this case, the desired is the tail, but the total, it can be a tail or a head. So the desired chance here is 1, which is the tail. Out of the total, it could be a tail or a head too, that is a half. So that's how we find the probability. We get the desired chance out of the total number of chances. And probabilities can be expressed as fractions, decimals, or percentages, meaning this can be expressed as 0.5. However, it can also be expressed as 50%, though we usually express them as fractions, except otherwise. Yeah, we usually express them as fractions. Then the probability of event A occurring is written as probability of A. So if I say probability of A, that's the probability of event A occurring, probability of B, probability of event B occurring, probability of C, that's the probability of event C occurring. Then the probability of event A not occurring is written as, sorry, here there's supposed to be a complement, it's written as a complement or probability of a complement, depending on how the question is framed. So you can say the probability of a complement or probability of a prime. So this means complement, the probability of event A not occurring. Now for any event, when you get the probability of event A occurring, when you get of A occurring plus the one of A, it should equal to 1. And how do we get that? Because if we have said the probability of A, the probability of event A not occurring, these two are equal to 1. It's their sum is equal to 1. What does that mean? Meaning if we have the probability of A, we can use that to find, if you have the probability of A complement, we can use that to find the probability of A. And we can keep interchanging. So here we have this. Okay. So we move on. We are seeing that probability of an event lies between 0 and 1. So that there can be no probability above 1 and it cannot go below 0. It cannot be a negative. Then the probability of an impossible event is 0, as we are going to see how these events are. A sure event is 1. Then both events occurring is written as A intersection B. This intersection sign means both. Then the probability of at least one of the events A or B occurring is written as probability of A union B. So union means the probability of at least one of the events occurring. Okay, now let us start covering some of the technical terms in this topic. So we have seen, we are going to start with, for example, you're given probability of A. What does probability of A mean? Probability of A, simply put, let me first draw this. And usually it's the sum of the probabilities is 1. The sum of all the, we say the maximum is 1. Yeah, so here we see that this is A, this is. So now let's say in this Venn diagram, we want to find out what is probability of A. Probability of A is this, simply, that is it. Now, how about probability of B? So I'm going to keep drawing this diagram such that we can understand what I'm saying. How about probability of B? Probability of A, then this probability of B. So probability of B is this. How about probability of A intersection B? So for A intersection B, what do? We look at this and we look at this. We look at these two. Where do they intersect? They intersect here. Yes, so this is probability of A intersection B, which represents this section. How about A union B? Probability of A union B is going to be, this is probability of A, this is probability of B. It's going to be everything that is shaded here and everything that is shaded here. And as we go in, this concept is going to be very helpful to help you in determining many of these unknown terms. Let's give an example. You're given what is probability of A complement intersection B complement, and we want to find out what is this region. So as always, this is how we are going to be determining these regions. You draw your Venn diagram as your side work. This is a probability of A, this is a probability of B. Yes. Now when you have this, you first ask yourself, what is probability of A complement? Probability of A complement means everything outside set A. So now when we shade everything outside set A, this is what we are shading, right? This is what we are shading. This is the probability of A complement. The probability of A complement. How about the probability of B complement? Now, to make it simple, I'm going to draw that using a different color such that we can see what I'm saying. Now, what's the probability of B complement? Everything outside set B. So everything outside set B is this, is this, is this, is this. This is everything outside set B. This is everything outside B. So this is B complement. So now why am I showing us this? Now when a question wants the intersection, it means where these two meet. And from what we have shaded, from our shading here, you realize that where these two things intersect is in this outside bracket. So meaning probability of A complement intersection B complement is this region here, meaning, let me show you here what I'm saying. That probability of let me show you what I'm saying here. This is A, this is B. That when someone asks me about A, this is the region. I don't know if it's making sense. And I think we all know that this region is the same as saying probability of A union B complement. So this is a concept I'm driving at. Let's give another example. Let's say now you're asked to find the probability of A complement union probability of B complement. Now for this case, for union, everything is supposed to be like everything that we have shaded here is in the union. What does that mean? If I was to redo that set for you and I want to represent what the union is, I come here and I do this, I do this. So the union, probability of A complement union B is the same as me shading everything that is outside this set. So even this, meaning probability of A complement union B complement is equal to probability of A intersection B complement. I don't know if this makes sense, because you realize here the only thing that is not shaded is intersection, meaning remember we said that the complement means everything outside that set, meaning the probability of A intersection B complement is the same as the probability of A union B, A complement union B complement. Now why am I stressing this? It's because in many numbers you're given, you ask to find the probability of, let's say, question can say find the probability of A intersection B complement. Now what we have covered so far, it makes it simpler for you to find out the region that is being required in the section. However, we are going to do a separate video just stressing this point, such that for those who have not gotten it, you can reference there, and it should first make sense to you, then you can go on with what we are saying with the different examples. Okay, so I think before we go, I can stress one last time what these different sets are. So this is probability of A, and this is probability of B. We have this. So this is the probability of A intersection B. So it's important you understand what each of these sets mean. This is the intersection. I think this one should make a point to most of us here. Now this set is the same as probability of A only. This is the same as probability of B only. Or this is also the same as the probability of A intersection B complement, the same as the probability of A complement intersection B. So this is what this means. Then now what is outside here, this is called the probability of A union B complement, or probability of neither events occurring. Neither events occurring. Okay, so I think before we go, we should first further look at a few key definitions. Yes, we should first look at a few key definitions before we go on. Okay, yes, so as we were saying, so to further drive the point home, I'm first going to explain this for a few more minutes. Okay, now when we have probability of A, probability of A, that's how we have this. These Venn diagrams really make it simple for you to interpret this information. So what is the probability of A? Then when I say probability of A complement, and I'm to draw it here, this is probability of A, this is probability of B. Probability of A complement is everything outside set A. This is everything outside set A. Everything. Now, the sum of everything here is 1, and also the sum of everything here is 1. So I think it should make sense when I say that the probability of A plus the probability of A complement is equal to 1. Meaning, the probability of A complement will always be the same as 1 minus the probability of A. Now, this concept, similarly, this concept, anything plus its complement is 1. Like, this is just the concept. Probability of A union B plus probability of A union B complement is 1. Similarly, anything probability of A intersection B plus the probability of A intersection B complement, its answer is 1. The probability of B plus the probability of B complement, the answer is 1. Why? Like, it's because when I say the probability of A plus the probability of everything outside A, it's like I'm saying the whole thing, it's equal to 1. Now, meaning when you're given the complement of anything, it's the same as having that thing, because you just have to subtract 1 minus. That's the concept that we are trying to carry. That similarly, if I want to get the probability of A union B complement, it's just a matter of saying 1 minus the probability of A union B. The probability of A intersection B complement is equal to 1 minus the probability of A intersection B. So with time, it should be as simple as you getting this, that get it in your head that any probability plus its complement will always be equal to 1. Alright. Now let's now further summarize with introducing a few key formulas. Though, however, as you're going to see that in this topic, once you understand that Venn diagram, you're not even going to need so much of the formulas crammed in your head. Why? Because all the formulas are going to be derived from the diagram. Let me give you an example here. So I think you should know that the probability of A union B is equal to probability of A plus probability of B minus the probability of A intersection B. However, another person, let's say you can just, once you've mastered the Venn diagram, these formulas can always they can always be, they can come simple. We say this is the probability of A intersection B, this is the probability of B, this is the probability of A only, so this is also a probability of B only, probability of A intersection B complement probability of A complement intersection B. Now, what is the union set? A union B represents everything here. Meaning, if I want to find the probability of A union B, I can also say it's equal to the probability of A, I'm just adding everything, plus the probability of A intersection B, plus the probability of A intersection B, but this is complement. Yes. Though now, however, the way this formula was derived was from this formula. So it was from this formula, because when you come here and you ask yourself what is the probability of A complement intersection B from here, you're going to realize it's the same as saying probability of B minus the probability of A intersection B. Similarly, what's the probability of A? This complement This is equal to the probability of A minus the probability of A intersection B. So when you come and substitute here, and you say now here, what is A? This is probability of A minus the probability of A intersection B plus the probability of A intersection B plus the probability of this is B minus the probability of A intersection B. So this and this cancel. So what am I left with? I'm left with the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. So what am I trying to drive home here? That this someone who has this formula from the Venn diagram can come up with the same answer as someone who has this. So that's why I was telling you that it's not mostly about cramming the formulas, but once you understand the Venn diagram, it's going to make 50% of the work very simple for you. And now when we have this, by just relating coefficients, meaning if I have probability of B union C, it's the same thing, probability of B plus probability of C minus the probability of B intersection C. Similarly, if I have probability of A union B, just by comparing, the same as the probability of A complement plus the probability of B complement minus the probability of A intersection B complement. Yes, so I think with this we are going to start doing our examples. We're going to start covering our examples and we can further dive into the topic.